Hello, welcome to the presentation. This is effectively part 3 of our 3-part series on the Stope Optimizer tool within GEOVIA SURPAC. In part 1, I covered the basics of your first run and how to get results. In part 2, I covered some more advanced situations and settings. And in part 3, I will be covering more of the post-processing, how to recode a block model from a block model, how to export from GEOVIA SURPAC to GEOVIA Minesched, and how to import the result into GEOVIA Minesched for scheduling. So first, it is important to recognize that there is 2 directions that can be done after the Stope Optimizer results are generated. Here in front of you, you see the results from a typical Stope Optimizer run. These are the results from part 1 of our series. If I click on a given block, you will see that there is a lot of metadata on top, and then the tons, volumes, and grades that will be used in Minesched at the bottom, as well as the Stope name. If we want to bring this into Minesched now without doing any editing, we will run into an issue where Minesched requires attributes to be real. These are not, and you can see because there is no R next to them. There would be an R here if they were real. So if we go to Solids, Solids Tools, SDM Tools, Modify Attributes, and we refresh, we don't have to select any given one because we want to change all of them for all of the translations. It will load up all of the attributes. We can scroll down to the bottom, and we can change these ones to real instead of text, as Minesched will require. Once we have done so, the function that we want to run now, and if we click on it, you can see that R has taken shape there. The function we want to run is found under File. Oh, we need to save this first. And we'll save this as export to Minesched. The file that we want to run is under File, Export, Generate SDM for Minesched. We select our file, which is going to be this export to Minesched, and hit scan, and it will show all of the attributes. Now we have to select which attribute we want to export, or which ones we care about importing into Minesched more accurately. And for that, we will select all of the bottom. We don't actually need SG because we have tons and volume. We then need to select a material attribute if we have one. So if you have a rock code attribute or a classification attribute, you can select it. Otherwise, just give it a material attribute name on top. The reason for this is because Minesched will import it as if it was a partial percentage model. So all of the attributes down here will become, in this case, or underscore tons, or underscore volume, or underscore AG, and so on. If you had a material class attribute, it would be material 1 underscore tons, material 2 underscore tons, material 1 underscore volume, and so on, down through all of the attributes. In our naming, and we're going to choose to rename translations. This will just make it a bit easier for it to come into Minesched a bit later. Once we have done this, we will hit apply, and it will generate the exported to Minesched compatible file. If I clear the screen and I bring that in, we will see that if we click on one of them, we will now have all the same metadata on top, and then or underscore tons, or underscore volume, and so on at the bottom. If we had not made those attributes real to begin with, none of these would be considered real. They would all be text attributes, and we need to make the changes now before going to Minesched. But that's if we do the simple case where we don't make any changes. There are many situations where we might want to change the results from the Stope Optimizer before bringing them into Minesched. We might want to change the shape slightly to align with our development. We might want to cut out crosscuts. We might want to split the stopes using tools such as Stope Design Tools Stope Slicer to cut them into smaller pieces, to try out different mining levels, different methods, and so on. For this, there is also an additional feature that I just wanted to bring to your attention here under Customize Default Preferences. If you are doing functions such as outersect or intersect, cutting out the crosscuts and the development, then I'd recommend turning on the Solids Intersection Library DS here under the Default Preferences Applications. This is leveraging tools from the CATIA library that we've now brought into GEOVIA SURPAC for doing these Boolean operations. And in support, we have found this to be of great benefit so far. So if you've ever had trouble with getting those intersections this is a tool that you might want to investigate. Once we've made those changes now, the tool that we have for updating from the block model can be found under Solids, Solids Tools, SDM Tools, Code Solid from Block Model. There is also a Code Polygon from Block Model, but we don't need to worry about that one. And a Code Solid from Block Model. We will select our webinar test 2, that is our open layer. Our block model is already populated because it was open, and we will select our attribute for our density. In this case, because it has to recalculate the tons from the volume, we need the SG attribute here in order to repopulate that. Give it a report name and choose our rock type attribute. In this case, we have to have a rock type attribute. In the previous example, when we used generate SDM for Minesched, we did not need a rock type attribute. We were able to just specify write one in. In this case, we need to have a rock type class for classification. And here we select our grades. AU, AG, CU, and NSR. This list is populated from the block model as well, and it will create the attribute if it does not already exist in the Stope. So if you have an attribute that you forgot to report during the Stope Optimizer function, you can go in here and code it here. And we will hit apply. It will take a moment as it has to go through every trisolation, but what it will do is a partial percentage cutting of the Stope using the block model and recode all of that information back to the Stope. Once it is done, we can select the block, and here you'll notice that it changed all of these to real for us. We didn't have to make that change here. It's still good practice to have gone and done it yourself, but in this case, it will do it for us. The relevant information. In this case, indicated and measured. These are our rock types from our block model. So if I go to color my block model by attribute and I select my class as 12, which is my rock type, we get indicated, inferred, and measured. We only have indicated and measured in our block model, so those are the only two that got coded into the Stope. If there was a single Stope here that had inferred, there would be a third category of inferred material. Now that we have all three, the last important thing of note is our Stope name. It is important that the Stope name be present in the metadata once the SDM file is created. So the SDM file consists of multiple sets of data. There is the description fields, which SERPAC users are very used to, and there's all of this data here as well, this user data. The user data has to have matching metadata for it to be relevant in Minesched. If we open up the Minesched compatible file, for instance, in our Notepad, we can see that at the top is all of this metadata, which will have Stope name, tons, volume, AG, AU, CU, and NSR. These are very important, as well as all of the __ versions thereof. If we open up, however, our new recoded block model, we will see that while it has the indicated and measured up top, it does not have Stope name coded in the metadata. If we scroll down to an individual object, however, we will see listed in the data in the individual object, there will be a Stope name. So what we need to do is just copy one of these lines, go back up to the top, and place it in the list up top. I will place it here, make everything align, and then delete the value from inside of value. And then save. And this will now make this file, it will recognize the Stope names when we go into Minesched. The last thing that can be done within SERPAC in the post-processing is classifying of the solids. Say we wanted our solids to be broken up by a classification field, say grade element. We want low grade, high grade, medium grade. Find our NSR. We have values ranging 68, 82, 75, and so on. So let's say we want to split them at 75, so greater than or less than 75. We can find that tool under Solids, Solids Tools, SDM Tools, Classify SDM. And here we're going to select our input. Refresh our classification name. So this is which attribute are we actually doing the classifying on, and if you want to apply a specific style. So if you have a style that you use for everything else that is low grade, high grade, and so on, you can specify it here. Here we'll specify the output. We'll call this webinar test 2 classified. And we're going to say object 1. Now we can give it an object name. And in this case, why not? I'll use low grade first. And I'll say low grade is from 0 to 50. Object 2 will be medium grade from 50 to 75. And 3 will be high grade from 75 to, I want to make sure it gets all of it. So I'm just going to say 4 nines. That's way too high, but that's what I'll use. And I'll hit apply. So now, when I open up the classified, it should be colored based on the NSR value. So this is 70 medium grade. This one's 87 high grade. There is no low grade into this because of the cutoff that I used for the purpose of SSO. A fairly common question that we get on support is how to automate things in SERPAC, how to assign stope names, for instance. There is the option, if we click on any given stope, we can go to Solids, Solids Tools, SDM Tools, Modify Attributes, and we can change them one at a time. In fact, we can do something like that, and we can change it here. The issue is that how do you automate that? How do you do it faster? And the answer to that is macros. So what I threw together here is just a simple macro to assign a stope name attribute. This is just the SCL iterate functions. The example for this is just copied and pasted from the help files. And I just changed in the trisolation what it is doing, and it is setting our stope name as stope_trisolation number. That's it. So this is just a very straightforward example. But what you can do is, in this example here, just to show a different idea, is you can get, say, the current level, and you can set it as stope current level. And then we would get level_trisolation number, for instance. You can do is that is incrementing numbers. You can set it so that it is assigning them based on the average Z elevation, X elevation, whatever is useful for naming it logically in your situation. This is just one example that I threw together. If you do use this method of a macro, just be sure that when you are changing the metadata in the SDM file to bring it into Minesched, that you make that metadata name match up with whichever one that you assigned for this function here. On the topic of the stope name attribute and writing that attribute to the block model as part of a macro, it is possible to do, but not using any SCL handles. So this macro is relatively simple. It's really just looping the SCL iterate command with the SCL set named attribute value command, as they're both SCL commands. However, for writing the name of the stope name attribute to the metadata, you would have to use you would have to open the file and read the file and then write to that file. There are two possible ways to go about that. We can use something like this, where we're telling the program to open the file, go to a specific position, read it, write the data that we want, and then write all the other data back in. The reason for that being that the insert command to computers is actually an overwrite function. So we need to tell it to essentially learn the entire function, write part of it, insert what we want, write the rest of it. The other way that can be used to work around this, if you are more familiar with importing packages, is using the insert into file function from the package file util. So this can also be used to open the file and then insert the data into the file, because it's a rather common ask. So if you are interested in building your macro in such a way that it also codes this Stope name attribute to the metadata at the same time as coding it into the block, into the SDMs, then there are ways to go about it. It's just going to be a little bit more complicated. So now I'm going to go to GEOVIA Minesched, and I'm going to show bringing in a function, bringing in an attribute here, bringing in a SDM model. So I created an underground project. It does have to be an underground project, just to note that here under configuration must be underground or surface and underground. I will hit the plus sign, and first I will bring in the Minesched compatible one that we did with the first method, and then after I will do the recoded one that I did with the second method. So if I open it up, I create a material class, and I'm just going to call this ore. Under our attributes here now, we hit our drop down, and if we had not changed the attribute type to real a little bit earlier, then when I hit extract, it would be empty. And in fact, I can just show you that. So I will just minus this, remove, and then add. And I will add, for instance, the first example that we had before we changed everything. And in the drop-down menu here, it will not populate because nothing is a real value. So now I will remove, and I will add our Minesched compatible. And now when I hit this update from model, it will extract everything. Now it's important to note that we are bringing this in as if it was a partial percent model. This was we found the best way for bringing all this information into Minesched, especially given the second scenario that we analyzed where we had it coded by rock type. This was the easiest way to do this. So we're going to do ore underscore volume here, and then ore underscore tons here. Now, the way that partial percentage models loading into Minesched works is that it will read this first attribute and automatically assign it to the quality attributes at the bottom. This is so that if you have multiple qualities, we do not have to list them as, we don't have to bring in the ore underscore AU and also rock type 2 underscore AU. We just bring in AU. So for these ones, we will select the ones that do not have ore at the beginning. So AU, AG, CU, and NSR. We'll change their names just to make them a little bit easier to find on charts. And we'll go over to validate and update. And you'll see that we did not change class 1. Let's just change that to ore to match the rock type that we entered here. Go over to validate. There we go. And it populates them with the volume and the mass and the 4 qualities that we brought in. If now, I will show the example of the one with multiple rock types. I'll clear everything. Hit the plus sign. And this is the one that was recoded now from the block model. This time there are 2 classes, indicated and measured. And we find the associated elements from both. So here we hit extract from model again, and we will find the indicated underscore volume and the indicated underscored mass. We will find measured underscore volume and measured underscore mass. And now it's easier to see why here we don't put the rock type underscore quality down here. So we're going to do AU, AG, CU, and NSR again. And here we can choose them from the dropdown. Those four again, AG, AU, CU, with the ones without a rock type at the beginning. Or we can just type them in here because we know what they are at this point. Oop, that should be NSR. There we go. Okay. If we go over to validate, it should now just update with all of the relevant information for indicated and measured. The last step to bringing it all into Minesched is to go over to our setup schedule, underground. The screen will populate. It takes a couple seconds the first time it loads, and we'll click on Add. It will automatically detect that an SDM model was defined. So then we're going to click on Continue, and this screen will pop up. You have a choice if the location type is either rings or stopes. If it is rings, you can choose all of the relevant ring information here. You will notice that when we hit the drop-down, what is populating at the top is that list of the metadata that I showed at the top of the SDM files. If we go back to SERPAC and I reopen this, it is the metadata that is on top that does not have a data type or density of applied. If it has a data type here as real, then it will not be brought in because it can't be a name for anything. If it has no value, it is text. So then it can be used. So in Minesched, that is what will be listed as the options here, is the text options. So you can group them if you like, if these are rings. If they are stopes, we select stopes, and our only two options are if we want to create a single location for the SDM file, in which case it will populate all of our stopes as one big location, which may be useful in some situations and less useful in others. Or, and we can delete this, we can choose to bring them in as separate locations using that stope attribute, and it will bring them in like so, so that each stope is a separate object. So now when we are scheduling, we can schedule each of the stopes separately. In this way, we don't need to change them into separate files or separate object numbers or anything along those lines.